Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir. Good morning, sir.
Okay. Unit 4 is going on and series, na? Series. Okay. Now, uh, the necessary condition for a convergence series. Necessary but not sufficient. Na? Necessary condition for convergence series. What is the necessary condition? For every convergence series un, if this is un is convergence series, then un is convergent. Wait 1 minute. Na? 1 minute. So if un is convergent, then limit n tending to infinity un must be equal to 0. So what is the necessary condition? If un is convergent, then we can say that limit n tending to infinity un equal to 0. But converse is not always true. But converse of the above theorem is not always true. That means the condition is not sufficient. Suppose we have a series 1 by root 2, 1 plus 1 by root 2 plus 1 by root 3 plus 1 by root 4 and so on. The series is actually 1 by root n up to infinity. Now we have to test the convergence of the series. So Sn is equal to 1 by root 2, 1 by root n. So this is greater than, we can write last term is greater than 1 by, last term is 1 by root n is same, but before that term we can write it, this is greater than 1 by root n and so on. So this is 1 by root n plus this up to this is n terms, up to n terms. That means this is actually Sn is actually greater than n by root n. That means this is greater than, Sn is greater than root of n. So limit n tending to infinity, Sn is equal to limit n tending to infinity root of n, or limit n tending to infinity greater than will be limit n tending to infinity root of n, and this is infinity. That means the series is, that means the series, which series? the above series, this series is divergent. Divergent. But un, what is un? Un is 1 by root n, and limit n tending to infinity un is equal to 0. So we see that the converge of the above theorem, that which theorem, if un is a convergent series, limit n tending to infinity un equal to 0, the converse is not always true. We proved this by an example.
So why are we writing Sn is greater than n by root n? So like this series we are forming is
Yes,
this.
sir.
Okay, actually, we have a P series. This is actually P series. Suppose this is actually P series. What is the P series? P series is 1 by 1 to the power P plus 1 by 2 to the power P, 1 by 3 to the power P, up to infinity. Now, this series is convergent. This series is convergent if P greater than 1. Okay, proof is not necessary for this P series. This series is convergent if P greater than 1, and divergent if P less or equal to 1. So this is an important result. This is an important result. Proof is not necessary. So what we did actually, 1 by root 2, 1 by root 3. This is actually which series? One form of P series, right?
Yes, sir.
Or P equal to half.
Yes, sir.
So this means
1 by 2.
this series is divergent. Okay.
Sir, can you show a small proof, sir? How is this, sir? Because convergent is fine if p is greater than 1, sir. Because if n tends to infinity, then 1 by infinity will be 0. Sir, if p is less than 1, then how are we still reaching infinite terms?
Okay, I actually proof is not necessary, but okay, I will post the PDF of the proof in our classroom. Okay,
Okay, sir.
proof is it take times a lot. I will upload the proof. Huh? Okay.
Yes, sir.
Okay.
And sir, above the step of Sn is greater than n by root n, the above step you have written that it is less than 1 by root n plus 1 by root n till n terms. What it means?
Ha. 1 by root n, right? So
Yes, sir. What
actually,
it means?
what Sn is greater than root n, right? So
Yes.
limit n tending to infinity is must be greater than.
Sir, Sn is,
So
sir,
this step
Sn is
came later,
greater
sir.
than
For
1
the
by root n
first
now.
step, sir, this came later. So the first step you have written 1 plus 1 by root 2 plus dot greater than 1 by root n. So how are we coming on that? Sir, are you comparing each individual term and saying that because n
Comparing
tends,
each term,
so
comparing each term.
because n tends to infinity, so 1 by root n will eventually be 0. So we are placing 1 by root n term for each 1 and then 1 by root n also for 1 by root 2, because 1 by root 2 will have some value that will not be 0, it will be greater than 0. So we are comparing that way.
Yes, sir. Like sandwich theorem we are doing now.
Right. Okay, I will upload the total proof for P greater than 1 and P less than 1 and P equal to 1. Okay.
Okay, sir.
Now, another results. There is another results. Another results for geometric series. Geometric series. What is the series? Series is 1 plus r square up to infinity. This series is convergent when mod of r less than less than 1. Second is divergent mod of r okay. Divergent when r greater equal to 1. Okay. And wait, this two. So for geometric series, these are the results. These are the results. So these two results are very important. Okay, now comparison test. If two positive term series, two positive term series un and vn. Actually, do we have two series un and vn?
Sir, in the geometrical series, divergent if only r equal to 1, no, sir. If r is greater than 1, then 1 by r minus 1. And if r is less than 1, then 1 by 1 minus r, no, sir. Sum of infinite terms in GP.
R equal to 1, then divergent.
Divergent when r equal to 1 only. If r
If
greater
R
than
greater than 1, also divergent.
how, sir? Sum of infinite terms.
If you take the Sn, so Sn will be r to the power n minus 1 by r by n.
Yes, sir. But sum of infinite terms is 1 by r minus 1.
This is Sn.
Yes, sir.
If r tends to infinity, r greater than 1, then Sn will be infinity. R greater than 1. Right? If limit n tending to infinity and r greater than 1, the limit n tending to infinity, this will be infinity. If r greater than 1. So for r greater than 1 also, this is divergent.
Okay.
Now we have two positive term series un and vn. Then if limit n tending to infinity, okay, for geometric series we also upload the I also upload the proof also. Huh? Okay. Now un by vn is equal to k. K means a finite number. Finite number. Then both the series converges or diverges together. That means if the nth term of the series un and nth term of the series vn is equal to the ratio is equal to k, a finite number, then we can say that both are both the series are convergent. That means if un is convergent, then vn convergent, and if un is divergent, then vn also divergent. Okay. Example. Test this series. This is convergence or divergence. Okay. Now by comparison test, un is equal to here, un equal to 1 by n plus 10, and take vn, the series vn, this is 1 by n. So nth term vn, nth term vm is equal to 1 by n. Now 1 by n, this series is convergent or divergent? This series
Convergent.
Convergence, sir.
Divergent series.
convergent or divergent by
Divergent.
this p series,
Divergent equal to
right? This is a p series, one type of p series, because here p equal to 1. This is a p series, or p equal to 1. Now p equal to 1, this means this series is
divergent.
divergent. The series, now look, the series 1 by n is divergent, but the sequence 1 by n is convergent. Okay, the series 1 by n is divergent, but the sequence 1 by n is convergent. Now, okay,
So what
so
does this mean?
what is?
So what does this mean when you said
No.
So-
Sometimes there is a questions. The series 1 by n is convergent or divergent, and the sequence 1 by n is convergent or divergent. Okay.
so the series sequence is convergent means the so this 1 by 2 1 plus 1 by 2 plus 1 by 3 dot 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 this will somewhere this will stop, right? So that's convergent.
Sequence is as n tending to infinity, limit is equal to 0. That's why
Yes.
this is convergent sequence.
And sir, the series will be
Divergent
so
by
because
p series,
by p series.
right?
So saying the series is divergent means the series extends up to infinite terms. That's why we are saying it's divergent, or why we are saying it's divergent. Like
The series is divergent by p series.
by p. So please send this proof.
Yes. Okay, now the ratio un by vn is equal to what is 1 by n plus 10 by 1 by n is n by n plus 10. Now limit n tending to infinity, un by vn is equal to limit n tending to infinity 1 by
10%.
this. So as n
One.
tending to infinity 1 by 1 plus 0, that is 1.
One.
That means a
It's finite.
finite number. That means un and vn are converges together
Both
or
divergent.
Now vn is divergent. This implies un also divergent by comparison test.
So what does this mean, sir? What's the crux of the sentence when we say u1 is divergent and v1 is divergent?
So Actually, we have to take the convergence or divergence. Actually, test the series. It is convergent or divergent.
Yes, sir.
So by comparison test, we can say that this series is divergent.
So what's the crux of that? So what does that mean when we say the Vn and Un both are divergent?
Both are divergent.
Yeah.
That means you need the proof. This
No,
is
sir, I don't need the proof, sir. I'm asking what does that mean when you say Un and Vn are divergent? What do you mean by this? So that UN, sir, UN is the start term when uh, and so Vn is like the extending term, right?
even is nth term of the series.
Yes, sir. Any term of the series, and Vn is the last term you're taking.
Vn is the nth term
Sir,
of the series
UN and
Vn.
VN are two different series.
Even and Vn two different series. And we know the characteristic of the Vn. So by comparison, we can say that the UN is divergent because we know the series Vn. Vn is divergent, but we do not know the series UN.
Yes, sir. So got it.
Okay.
Sir,
Huh.
sir, but UN by Vn is not equal to what you have selected the question. It's n by n plus 10. It's not 1 by n plus 10.
1 by 1 by n plus 10, right?
Yes, sir. And UN by Vn is equal n by n plus 10.
N by n plus 10, right? Here.
Yes, sir.
Okay. Right?
Sir,
Yes, sir.
Bolo.
how this comparison test holds good, sir? Actually, we are comparing UN and VN, that is sequence, no, sir. Is equal to finite number, then UN becomes
No, sequence not. Nth term of the series. Nth term.
a series means actually if you want if a sequence is convergent or divergent, we are comparing only nth term, no, sir, for sequence. Means by this we can tell only the sequence is convergent or divergent. The entire series, how it will be convergent series, sir. Like we are just comparing the nth term by n tends to infinity, sir. Not we are comparing sum, no, sir.
We are comparing the nth term of the series UN and the nth term of the series Vn by a ratio test. What is the ratio? UN is to Vn. If UN is to Vn, matlab, the nth term of the series UN and nth term of the series Vn is equal to a finite number, then we can say that both convergence or divergent together. Let's take another example. Now test the convergence of the series. Test the convergence. Test the convergence. First, we have to find the nth term. Nth term of the above series. Let UN. So what will be the nth term? 1 by, say someone,
under root n plus 1.
By root n plus
okay. Now we can write this n plus 1 by n, that means 1 by, right?
Yes, sir.
Now let Vn is equal to 1 by root n, because we know the property of Vn. Vn is series 1 by root 2
So this is
plus 1
divergent
by
series.
3. This is a divergent.
Divergent series.
So Vn is divergent. Divergent. That means Vn is known to us. This is known to us. Now Un by Vn. There will be Un is 1 by root n, 1 plus
So
n,
this should come in numerator.
and 1 by root n. That means it is wait. 1 by root n this is Un by Vn. That means this. Now 1 by root n, 1 by root n cancels, and this will be limit as limit n tending to infinity. Limit n tending to infinity. This will be 1 by 1 plus
1.
1 plus 1, 1. So this will be half. This is a finite number. Finite number. Finite number. That means Un and Vn both convergence or divergence together.
Sir,
But we know that Vn is
Sir, you have
divergent.
sir,
written, sir, you have
Ah,
written
it
UN
should come in.
incorrectly.
Yes, sir. That should come in numerator.
Exactly.
हाँ बोलो.
UN
Sir,
वाला
UN
term
should be.
numerator कहाँ आएगा?
What is the problem? Un is equal to
Sir, जो 1 plus root वाला जो part है वो numerator में आएगा instead of coming in the denominator.
इसका आंसर what 2 होगा. 1 by 2.
yes. Right, yes. Oh, yes.
Sir, just write it Vn by Un.
Right. Yes. 1 by this, and this will be 1 plus this is Un, na? And Vn is will be
1 by
Sir,
root n.
right.
Vn
Root
is
n.
Vn
Yeah.
only correct, sir.
Right. So this will be n tending to infinity. 1 by root n cancel, and this will be actually 1 plus this, right? So this is 1 by 1 plus 0, it is 2. So this is also finite number. Finite number. That means Un and Vn converges together, and since Vn is divergent, this implies Un is also divergent. By which test? By comparison test. Comparison test.
Excuse me, sir. Sir, what if the by after comparison the answer comes 0? Because if we write it Vn by Un, then it will be infinite.
Answer is 0 means?
Sir, we are comparing Un by Vn. So after evaluating Un by Vn, if we get 0, then Because if we write Vn by Un, it will become infinite.
Uh, the comparison test says that the number is finite number. Okay, if k0 is a finite number.
Yes, sir. 0 is finite, but infinite, reciprocal would become infinite.
Reciprocal infinite, but reciprocal un by vn is finite, then convergence or divergence together. Okay.
Sir, means he is saying that un by vn is equal 0. But if we write vn by un, that will become infinite. Then how would it be correct?
vn by un, vn by un. But we take vn, and we calculate un by vn.
So we would be concerned about Un by Vn only, sir.
un by vn.
Okay.
Okay. We take such vn such that un by vn we consider.
Yes, sir.
Sir,
Bol.
sir, will we take Vn from only P series?
No. You can take any series,
Any non-series?
any known series.
Sir, actually in the before sum, Vn is not a P series, no sir.
And what? So first you have to prove Vn is convergent or divergent first. Okay. You can say here Vn is convergent or divergent by P series or by क्या है वो? By
Geometric
geometric
series.
series. If you take any series that is not a P series or geometric series, then you have to first prove that Vn is convergent or divergent. There are many methods we are coming. There are many methods. Okay.
Sir, considering the previous example, if we know that 1 by root 10 plus root 10 plus 1 is divergent, and now we have to find that 1 by root 10 is divergent or convergent. So if the constant now is 1 by infinity, then
1 by infinity what? 1 by root 10 is
now
divergent.
it comes 1 by infinity, 1 by 0, 1 by 0.
This series Vn 1 by root 10, 1 by root 10.
No, sir. Taking not this series, I am talking about if we are given two series and the constant is coming 0, then we are given that second is divergent and first we have to find. But in another question, we are given first and we have to find second is divergent or convergent. So then we cannot apply comparison rule.
Suppose you have to check un convergent or divergent. Okay. Now you take a Vn, series Vn, which is known to you. Then you apply ratio comparison test by taking un1 Vn. You have to check un is convergent or divergent and take a series Vn which is known to you. Then you apply comparison test. Okay. Now examine the series, convergent or divergent. So this is our unknown series, and find un. Nth term. What will be nth term? Root of, say someone,
n plus 1, sir.
N plus 1.
n plus 1 minus 1 by
n plus 2 cube.
n plus 2 cube minus 1.
Minus 1.
Okay, now root n common, so this will be 1 by 1 plus n minus 1 by root n by n cube. So this will be 1 plus 2 by n cube minus 1 by n cube. So this is actually 1 by n to the power 3 minus half. 3 minus half means 5 by 2 cube minus n cube. Now take Vn is equal to the series summation of actually n to the power 5 by 2, this series. Now this Vn series,
It's convergent.
Vn series is n to the power 5 by 2. That means this is a which series? P series.
Yes, sir.
This is a
P series and convergent because power is
series.
greater than 1.
Right. This is a P series and P greater than 1. So this means, this implies this is a convergent series. That means the series Vn is known to us. Is known to us. Now we compare. We compare what? The un by Vn. So un by Vn will be actually 1 by n to the power 5 by 2, this cancel, and we get limit n tending to infinity 1 plus 1 by n.
Sir, we are saying that is P series. What is the P, sir?
Is the power. Power, which power?
5 by 2.
1 by which? Wait. Yes. Is the power 1 by 1 to the power p, 2 to the power p, 3 to the power p. P is the power. So this will be actually 1 plus 0 minus 0 by 1 plus 0 cube minus 0, that is 1. So this is finite. Now we know that Vn is convergent. Since Vn is convergent, this implies un is also convergent by comparison test. Now, take another important example. 2 by 1 to the power p, 3 by 1 to the power 2 to the power p, plus 4 by 3 to the power p, 5 by 4 to the power p, like that. Test the following series for convergence. So here un is equal to what? N plus 1 by n to the power p. Now so in common 1 plus 1 by n to the power p. So 1 plus 1 by n to the power p minus 1, and take Vn is equal to 1 by n to the power p minus 1. Now limit n tending to infinity, un by Vn is equal to 1 by n to the power p cancel, and this is 1 by n, limit n tending to infinity, this is 1. That means both are convergent or divergent together. Now, but here Vn converges when? Vn converges when p minus 1 greater than 1.
Yes, sir.
That means that is p greater than 2, and divergent when p minus 1 greater equal to 1, that is p less or equal to 2. That means the given series, so given series is convergent if p greater than 2, and divergence when p less or equal to 2.
Okay, sir.
Okay, ठीक है. Next day, another test, D'Alembert ratio test, Abbott test, ये सब होगा. ठीक है. और वो p सीरीज का जो प्रूफ है, कन्वर्जेंस और डाइवर्जेंस का जो प्रूफ है, वो मैं अभी अपलोड कर रहा हूँ. ठीक है, चलो, थैंक यू.
Thank you, sir.
Thank you, sir.